Okay, this is Unit 4, I do review. So number 1 says Stevens JROTC is selling popcorn and candy. They sell a total of 24 treats. The number of candy is 4 less than 3 times as many popcorn. Write a system of equations and find out how many of each treat that they sold. So in order to solve this, we're going to underline the two important sentences that tell us where our equation are. So the first sentence we're going to underline is right here where it says popcorn and candy and total of 24 treats. That's going to give us our first equation. The next part, it's going to give us our next equation is the number of candy is 4 less than 3 times as many popcorn. So before we can write this into equations, we need to define our variables. So I'm going to let x equal popcorn because that's the first thing we're talking about, and y equal candy. So anywhere we see popcorn and candy, we're going to write x and y. So x and y. Oops. Right here, x. Okay, so from here we can start writing our equation. So we have popcorn and candy, so that's going to be x plus y for a total of 24 treats equals 24. That's our first equation. To write our second equation, we have the number of candy, which we said is letter y, so y equals is 4 less than 3 times as many popcorn. So first we're going to do 3 times popcorn, which is 3x, and 4 less is going to be minus 4. So these are the two equations we're going to use. So on your calculator, in order to find the answer, you're going to go to graphs, then you're going to write delete 6, type our two equations, and then in between our two equations, don't forget the tab button, and then it's menu 6, 4. So after you do all that, you will get the answer 7, 17. 7, 17. So if I was to write this in a sentence, it would be that JROTC sold 7 popcorn, because popcorn was X, and 17 candy. Okay, let's look at the next question. The next question says, Miss Rojas went to main event on Saturday and Sunday. On Saturday, she bowled 3 games and played laser tag 10 times for $44. Sunday, she bowled 6 games and played laser tag 8 times for $60. Write a system of equations and find out how much it costs to bowl 1 game. So the first equation is going to come from what she did on Saturday. So Saturday, she bowled 3 games and played laser tag 10 times for $44. So that's going to be our first equation. Our second equation is going to come from Sunday, where she bowled 6 games and played laser tag 8 times for $60. So before I write my equations, I need to define my variables. I'm going to let x equal bowling and y equal laser tag. So if I was writing the first equation, the one that I underlined in red, it says she bowled 3 games. So 3x, and she played laser tag 10 times, plus 10y is equal to how much she spent? $44. So we're going to do the same thing for the second equation. On Sunday, she bowled 6 games, so 6x, and played laser tag 8 times, plus 8y is equal to her total cost of $60. So we're going to do the same thing we did on number 1, graphs, delete 6, menu 6, 4. Once we do all that, we get the answer 6.89, 2.33. So if we were to write a sentence, it would say that bowling cost, remember bowling is X, cost $6.89, and laser tag cost $2.33. So for every game of bowling, they paid $6.89, and for every game of laser tag, she paid $2.33. Okay. Remember, these are going to be the type of questions that are on the test tomorrow. So if you're still confused, when this is done, you can ask me a question. Bless you. Okay, so number 3 says a bag contains 42 coins consisting of dimes and quarters. The total amount of money in the bag is $6.75. Write a system of equations and find out how many dimes are in the bag. So in this case, it only wants us to find dimes. So I'm going to first underline what's going to be in my first sentence. So it's going to be 42 coins that have dimes and quarters. And then in my next one, it's going to be total amount of money and $6.75. So the reason they don't give us that many numbers is because they're assuming that you know that total amount is talking about how much a dime and quarter is worth. So we know a dime is worth 10 cents, and we know a quarter is worth 25 cents. So those are where our other two numbers come from. So if we were going to write the equations, first I'm going to define my variables. So let x equal dimes and y equal quarters. The reason we're defining our variables as x and y is because you're not able to graph an equation if it's not in terms of x and y. So looking at example 1, it says 42 coins consisting of dimes and quarters. So there's a total of 42 coins. Some are dimes and some are quarters. So 42 equals x plus y. The next one has money in it, so that's when we're going to use the dollar amount per each item. So it says the total amount of money. So there's some dimes that we know are 10 cents each, and there are some quarters that we know are 25 cents each, for a total of $6.75. So 0.10x plus 0.25y is equal to 6.75. So you're going to do the same thing. You're going to graph this on your calculator and use menu 64. After you do that, you get the answer of 25,17. And remember, it only wants us to find dimes, and we knew dimes is our x value. So our sentence would be, there are 25 dimes in the bag. There are 25 dimes in the bag. If they were asking for quarters, we would say there are 17 quarters in the bag. Okay, that's it for number 3. Let's look at number 4. Number 4 gives us two systems of equations, and it wants us to find the y value. Remember, in order to solve system of equations, we solve it on our graph. So you were going to use your calculator and go to graphs. And then once you type in both of these equations, you'll use menu 64. Once you do that, you'll get the answer -3, -5. But it only wants the y value. Only the y value, so our answer is y equals -5. This is going to pop up on the test where they're going to tell you to solve a system, and they're only going to ask you to write one value. So make sure you pay attention to this part, very important. Okay, let's look at number 5. Number 5 is very similar. It gives you two systems of equations, and you're going to graph this on your calculator. So you're going to go to graphs, you're going to do menu 64. And this time it's looking for the x value. So if you graph this and do menu 64, on number 5, you're going to get -4, 4. But since it's only asking for the x value, our answer is going to be x is equal to -4. So make sure you pay close attention to this because this will be on the test. Okay. I'm going to have to skip down to 6. Okay. So number 6 is the one where we had to use lists and spreadsheets. It says the tables of ordered pairs represent some points on graphs of t and h. So it says write a system of equations. That's all we're doing. We're writing them. We're not solving them. So if you use list and spreadsheets, remember on list and spreadsheets, we had to type in the table. And then once we typed in the table, we went to data and statistics, which was that purple icon. And then we typed in the values menu 461. So I'm not showing you all the steps here because we have notes on this. If you need more clarification, the video before this has shows you exactly on the calculator how to do lists and spreadsheets. So once I did lists and spreadsheets, I got, for the first table, y is equal to negative 5x plus 9. And for the second table, I got y is equal to negative 5x plus 27. However, even though these are our answers here, on the test, it might put it in standard form. So remember, when we have standard form, x and y have to be on the same side. So if I was to move the x's over here, I would have to add 5x, which makes my new answer 5x plus y is equal to 9. Remember, x and y's have to be on the same side. Same with this one. I would add 5x, I get 5x plus, I get 5x plus y is equal to 27. So these would be the answers that would pop up on the test, the standard forms. Something important here is that remember that the number before x, remember we called that a, cannot be negative or a fraction. It can't be negative or a fraction. So if it was negative, we would multiply every term by -1 to make it positive. If it was a fraction, we would multiply everything by the denominator. So if it was 1 over 5, we would multiply everything by 5. So everything by the denominator. Okay, so let's look at number 7. Number 7 says, how many times do the lines 7x plus 3y equals 0 and 14x plus 6y equals 0 intersect? So this is something, again, you're going to go to your calculator, and then you're going to go to graphs, type delete 6. Remember, once you graph this, it's just asking if they intersect. So on your calculator, what it would look like is something like this. So this first equation that I'm going to box in red looks like this. This is just a rough sketch. It's not exact. And then the other equation that I'm boxing in blue looks like this. So what you see is that these two lines are right on top of each other. And if they're right on top of each other, that means they intersect infinitely many times. So infinitely many times. So infinity. That's only if it looks like a one line. If the graph looked like this, let's say it looked like this, it intersects. This would be one solution. Remember, this is a perpendicular line if it intersects. If it doesn't intersect, and it looks like two parallel lines, that means it's no solution. So just something to keep in mind for the test. If it intersects, it's one solution. If it's parallel, it's no solution. If you see one line, it's infinite solution, or just remember infinity. One line is infinity. Okay. Number 8 says, how many solutions does the graph have? So if we just look at this graph, it looks like it never crosses anywhere. However, remember our lines are infinite. They can go on forever. So if I take this first line and extend it out as far as I can, and if I take the other line and extend it out as far as you can, Notice that it does cross one time. It crosses right here. So since it crosses one time, we notice in number 7, it crossing means it has one solution. So one solution. That's the answer. So keep that in mind when you're on the test, that they might give you some graphs that look tricky. You just have to extend the lines. Okay, we're almost done. Number 9 says graph the solution set of the following inequalities. So something important I want to point out is that since these have less than and greater than symbols, we know that both of these are going to be dotted lines. So we're going to graph this on our calculator, same as we were doing before, and then you're going to color in the shaded areas. So on number 9, your graphs look like this. So this is going to be the first one that I'm going to box in red. The first one looks something like this, and it was shaded down. And then the second one that I'm boxing in blue looks something like this. Remember, they're both dotted, and it was shaded down. So that means on your calculator, that purplish area is going to be right here at the bottom, where they both intersect. This is where they both intersect here. And that's all it wants you to do, is just graph it, just to see if you're able to graph it and see the difference. So on the test, they're going to give you, it's going to be multiple choice. You're going to have a bunch of equations. You're just seeing if any of these equations match the graph, and you can do that by looking on your calculator. Okay. And if I was to give an example of a point that's in the solution, an example solution would be 0, -10. Because 0, -10 is where both the shaded areas intersect. It's where both shaded areas intersect. Okay. Number 10 says, are the following ordered pairs in the solution set? So again, this is something you're going to graph on your calculator. That graph, since it has a greater than sign, is going to be a dotted line. The graph looks something like this and is shaded up. And then it's asking if any of these points are in the solution. So remember, we know it's in the solution by the 3 S's. So it's in the solution if it's shaded in the shaded area, or if it's on a solid line. So we need to check each of these points. So the first point, 8, 2, is over here. It's not in the shaded area or on a solid line. 6, 5, I know it looks a little off on your paper, but it's supposed to be up here. It's supposed to be on that dotted line if you're looking at a graph. So since it's on a dotted line, again, this is not a solution. So dotted lines equal no solution. Lastly, we have -5, 3, which is up here somewhere, which is a solution. So this would be our answer, -5, 3. So that's how it's going to look on the test. They're going to give you a bunch of points, and you have to determine if they're in the solution or not in the solution. Okay, last one. Last one says graph the following inequality. This is going to be an open-ended problem. It's going to look exactly like this. You're going to have to graph it on your own. So what I suggest you do is go to your calculator and then graph it. And then in order to make sure you're graphing it correctly, look at those x-intercepts and the y-intercepts. I'm going to go ahead and graph it by hand. So remember, if I graph it by hand, this 4 is my y-intercept. This -2 is my slope, so down 2, right 1, down 2, right 1. This symbol right here, this is going to be very important. If you get this symbol wrong, you're going to get points taken off. This has a line under it, so it's a solid line. So my solid line is going to go through here. And since this is a greater than or equal to symbol, I'm shading everything on the top. And that's it.